Yeah, so guys, in case you're confused about it, the username you log in with is guest and then the number. So if your number was 3, you're using guest003. The password is the random characters that go beside that. Okay, guys, so another thing that you might notice that might give you some trouble when you're trying to log into SciNet. So I'll open it up again to show you. It asks for a password. You're typing stuff, you don't see anything. That's a security issue or a security measure. You're not seeing anything so that if someone's reading over your shoulder, that person can't read your password, but what you're typing is being entered. So just type it and it will go in. Okay. Put your hand up if you're in, if you see something that looks like this. Okay, so that's the majority of us. So for those who are still having trouble, if the counselors can go around and help them out. For those of you that are in, this is just the login node. We can't use these nodes to do any computation work because this isn't the node that's meant for computing. So we're going to SSH, and it's going to SSH within SciNet itself, and we're SSHing to GPC-01, so GPC-01. Yeah. Can you guys see the screen better if I do that? So now what we're going to do, we'll go over to our SciNet accounts and run Python. And to do that, first we have to type module load Python. And it needs all that. So in order to do that, we'll also have to load these. So it says depends on these modules. So you can actually copy and paste in PuTTY really easily. So select this text that it says it needs. Actually, these are all GCC, so just select one. And then left click. That's actually going to copy. So now we can type module load, and then right click will paste. Or you can also just type it out yourself. Yeah, so to copy in PuTTY, you select text, and then when it is deselected, when you left click, that's going to copy it all. And when you right click, it pastes. So any one of these things that says it depends on. So like GCC/4.7.2 will work. You can also type it out. And you're going to module load that.
From here, what do I write?
And once you've loaded GCC, then you can actually hit the up arrow, and that's going to get previous commands entered. And do that till you get to module load Python. You can also type it out again, and then hit enter. And now it's complaining about Intel, so we're just going to module load Intel Python. And that'll work. So that's loading both the Intel module and the Python module, because Python also wants Intel.
Why there's so many?
Oh, I just did that to move it up to the top.
Oh.
Yeah. Who has got Python loaded? Okay, so what you can do now is just type Python, and now you can run the Python shell on SciNet. Put your hand up if you're still having trouble. Okay, it looks like the majority of us have gotten Python to start working properly. So now we're running Python on SciNet. There are a couple things that we can do with that. So let's get a sense of the queuing system. In SciNet, we have a special command that will submit something to the queue, and that's the SQ-sub or the Q-sub command. So we'll use this second one. But before we enter that, we have to actually create. So what this one does is -L basically means information about the job. So the number of nodes it needs to run. Right now, we're just going to run it with one node. The number of processors per node, in this case 8. It'll complain if we do anything but 8, because SciNet can't actually split it between the processors. So if it tells us to run on just one processor, then it means the other 7 are going to be wasted. So we'll leave it with 8. Wall time is 15 minutes, so that gives SciNet an idea how long the job is going to take, so it can schedule it. And /run.sh is the shell script that we're actually going to run. You can try it now. It won't work because run.sh has not been created. So to create that, first exit out of Python if you're in it. You can do that with Control D. That tells it it's like the end of the file. And now we're going to vim run.sh. run.sh. You can call it whatever you want. So in this file, all we're going to type is Python and then s.py. You can call it whatever you want. We'll just make a script of that. Put your hand up if you've got that, if you're at this point. OK. If you're having trouble, you can put your hand up and a counselor will come around and help you. So we've saved that, or we've written that. So now we're going to save that. So remember, escape:x. That'll save and exit. And now we're going to create s.py. So in s.py, we can create whatever we want. So we're going to go vim s.py. And now this is a Python file, so we can write valid Python in it. So I'm just going to print a value. So say print 4. You guys can do more after what? OK, so we save the run.sh. And then we're going to vim s.py. Yeah, so that's just selecting the brackets, but yeah, it's print 4. And once you've entered that Python script, you can go ahead and save that. So again, escape:x. So the cat command basically tells Linux to print out whatever is inside the file. So when we're done, your run.sh should say python s.py. Your cat or your s.py should say print 4 or whatever you want to do in Python. So put your hand up if you have those two files created that one does something in Python, one runs the Python. OK, put your hand up if you do not have that. So for those of you who do have the run.sh, you can now run it. So to run that, just go or actually before we run it, if we try to run it right now, so /run.sh, it won't work because we have permission denied. The reason is because it thinks it's just a text file and it can't run that text file. So we're going to change the permissions. So type chmod. It's not showing up because my internet's a little sluggish. So chmod 777 run.sh. What that does is that changes the permissions on run.sh and allows it to execute. So 7 means that you can have full write or full access over it. So read, write, and execute. The reason that 7 is 7 in binary is 1, 1, 1. And that puts a 1 in those 3 columns of read, write, execute. So once you've done the chmod, run.sh now will run. And so we can type /run.sh. It will call our Python, and our Python will run. So I'll bring that up, right? So run.sh, and that will call our Python. Anyone else having problems? Put your hand up if you've got it, if you're running run.sh and it's running your Python. OK, that's most of the people who hadn't before. OK, so why did we put that Python command into a run.sh? sh is a shell command. Why can't we just run it with Python? Any ideas? Yes. No? So, yeah. Oh, so I just did that to show you what each file should contain. Yeah. So the reason that we actually have to encapsulate it in that shell is so that we can run with the queue. So the queue can't run Python. We can't tell it to run Python because it's a command and another script that it's running, but it can just run a simple shell script. So now what we're going to do is we're actually going to do this Q sub. Right, so now we've created run.sh, now the Q sub will work. Oops. So this second one is what we want to enter. So at your command prompt, type out what that says. Right, make sure it's the second one here. Be careful that this is a colon, this is a comma, and this is an L, not a 1. Okay, so I think a lot of you have got it to run. When you do, what you should have seen is a number.gpc-sched. Right, that means that it's been scheduled to run on the general purpose cluster. So that job is now in the queue. It should, like that's a very short job. You only gave it 50 minutes, one processor. It should have run almost immediately. So if you type ls, that will show you the folder contents. Mine is being released. Oh, yeah, there it is. So you'll see if it ran 2 pieces of output, run.sh.e and your number, and run.sh.o and the number. So E is the error and O is the output. So if your program ran correctly, then you'll see in error should be nothing. So I'm going to cat, that's going to print the contents of error, run.sh.e, and it shows nothing, so that's good. And then I'm going to look at the O, and we see a couple things here. We first see this prologue. It's just general information about the job we're running. Then we see the actual output, and then we see the epilogue, and that's how long it took, what it actually used, that sort of thing. So that is in, if you hadn't seen, your O. So run.sh.o and then the number. Put your hand up if you have that, if you're getting that. Awesome. Anyone else?